This video is a brief review of all of the formulas and what we learned in sections 11.1 to 11.4, plus the extra area formulas that we covered. So if you recall, in section 11.1, this is where we covered circumference and arc length. So recall that the formula for circumference was 2 pi r, or pi times diameter. The formula to find the length of the arc, and this is if you took a piece of string and you laid it across like a piece of pizza crust and then took it and measured it. That's what we're finding when we're finding the length of the arc. So you can either, depending on what's given to you, you're going to take the measurement of the arc in degrees over 360 and then multiply that by circumference. If they're asking you to find a radius or they give you a radius, you would do the measure of the arc over 360 times the circumference formula of 2 pi r. You could also, if they give you a diameter, you could also do the measure of the arc over 360 times pi times the diameter. So that is what was covered in section 11.1. In section 11.2, this is where we learned the formula for area of a circle and area of a sector. So like a piece of pizza or a piece of pie. So the formula for area of a circle is pi r squared. The formula for area of a sector, that was the measure of the arc over 360 times the area, or let's say they give you a radius, the measure of the arc over 360 times pi r squared. So those will give you the area of the sector. The next section was 11.3, and this was area of regular polygons. So area of regular polygons. And the formula that we learned to find the area of a regular polygon is area is equal to 1/2 the apothem times the number of sides times the side length. Another way you can memorize this formula is 1/2 apothem times perimeter. Because remember, perimeter, to find the perimeter of any shape, is you take the number of sides and you multiply it by the side length. Now remember, this formula is for only regular polygons. So when we covered this section, we covered examples where we did 3 examples without a calculator. So without a calculator, we found the area of equilateral triangles. We found the area of a square, and we found the area of a hexagon. So these were the 3 examples we did in the notes where we did not use our calculator and we ended up using special right triangles. So we also learned how to calculate the measurement of a central angle. So in the case of the equilateral triangle, know that all 3 angles here would be 60 degrees. So we would actually have 2 different ways that we could do this. We could either find the center, find the measurement of the central angle, which would be 120, and then we could split that and then make that a 30, 60, 90 right triangle. And then from there, get the measurement of the apothem. We could have also divided this into one large 30, 60, 90 right triangle. Then over here would have been the 60-degree angle, and up here would have been the 30. And we could have also found the missing pieces that we needed to calculate this. Remember, the side across from the 60 would be whatever is across from the 30 with root 3, and then over here would be 2x. For the square, this one we would use the 45, 45 right triangle, because again, recall that your central angle here would be 90 degrees. Now, you could have also done the diagonal and multiply the diagonals and divide by 2. But again, you could turn this into a 45, 45 degree right triangle. And again, memorize the relationships of the sides. Would be x, x, and then x root 2. And then you can find your missing pieces. Then the last one was the hexagon. Again, calculate the measurement of the central angle, 360 divided by 6. This central angle is 60. Again, you can drop down your apothem, create your right triangle here. The 60 gets bisected, so now it's 30. And then from there, this would be x, x root 3, and 2x. So this would end up being your apothem, which would be here. So either way, you're going to be using special right triangles to find these different measurements. Then we also did without a calculator, with a calculator. So we also did calculations using our calculator. So for example, when we did a pentagon, here we needed to use our calculator, and we also needed to use SOHCAHTOA. So for example, if I have a pentagon, I'd have to calculate the measurement of the central angle. So I would divide 360 by 5, and I would get 72 degrees. Once I put the 72 degrees in here, and then if I pull that triangle out, once I draw in my apothem, then I no longer have a special right triangle. I've got a 36-degree angle up here. And then from there, I would use SOHCAHTOA in order to find either a side length or the apothem. And we did examples of these in the notes and in the homework. We also covered, we reviewed extra areas that you've probably seen before. So the extra area formulas that you need to know for the quiz is we reviewed area of a rectangle, and that is either length times width or base times height. We reviewed the formula for area of a triangle, and that's either 1/2 base times height or base times height divided by 2. We reviewed the formula for area of a parallelogram. So it's like a slanty rectangle. Again, the height is going to be next to the right angle. So this could be your base. Your height could be here, and that is base times height. We also reviewed the formula for area of a rhombus, and that was 1/2 diagonal 1 times diagonal 2. We also covered formula for area of a trapezoid, and that was 1/2 height, and then times base 1 plus base 2. So again, a trapezoid could look like this. Base 1 would be here, base 2, and then we could draw in the height. And a lot of times perhaps the height may be missing. They may give you this measure of this angle. They may tell you that this is an isosceles trapezoid. And then from there, you would use your special right triangles. You would figure out how long this is, how long the height is, or what the measurement of the height would be. And then from there, if this were to equal, say, 6, then this base would be 6. Once you found these two measurements, you would add it to get the total length of base 2. And we did examples like that. So you may have to find a missing height before you can even do the problem. But if you're given the height, the base 1, the base 2, then you just plug it straight into the formula. And the last section on the quiz is section 11.4, and this was the geometric probability. First thing that we covered in this section was to find the probability if you had a line segment, so dealing with length. So let's say I gave you a line segment and I labeled it with 3 points, and I told you the length from A to L was 3, and then the length from A to M, I could tell you that that would be 11. And then if I asked you what would be the probability, so what is the probability that a point picked at random from segment AM would fall on AL. So again, to calculate that, you would find the length of AL over the total length of AM. AL was 3, AM was 11, and if it asked you to leave it in as a simplified fraction, we would stop. They could also ask you to convert it to a decimal or a percent. So 3 ways to write probability is either a fraction, decimal, or percent. And then the other type of probability we covered was, for example, if I gave you a rectangle, and in that rectangle, let's say I drew a circle, and let's say I asked you what would be the probability that a point, or a dart, we could say it's a dartboard, that a dart would fall into the shaded region of the circle. So here, so probability that, let's just say it's a point, that a point would lie in the shaded region. So again, we would do the area of the circle, what we're aiming for, over the area of the rectangle. So let me go ahead and give you some numbers here so we could actually calculate this probability. So let's say I told you it had a radius of 5, And let's say my rectangle was 15 by 10. And again, it's not drawn to scale. So area of a rectangle, base times height, or length times width, so that would be 150. And then the area of the circle is pi r squared, so 25 pi. And then we would need to reduce the fraction. I can divide them both by 25, and I would end up with pi over 6. And that would be the probability. Let's say I switch it around, and let's say instead of asking what would be the probability that it's in the shaded region of the circle, let's say now what would be the probability that it's in the shaded region outside of the circle. So for this, I would have to do the area of the rectangle minus the area of the circle to get that shaded area over, again, the entire rectangle. So again, we could use the same dimensions, use the radius of 5, 15, and 10. So again, the area of the rectangle, 10 times 15. 10 times 15 minus the 25 pi. So 150 minus 25 pi over 150. I could actually divide them all by 25. And then this would now become 6. And that's a 1, and that's a 6. And then my simplified answer here is just going to be 6 minus pi over 6 if I wasn't using a calculator. If I was using a calculator, I would do 6 minus the pi button divided by 6. But we'll go ahead and leave it just like that. So this is what we covered. This is the information that will be on the quiz. Make sure you have all of your formulas, either memorize them or have them written down. Have your calculator ready to go. And again, you will need 2 devices for the quiz. One, you'll need your iPad to take it on, and then you'll need another device which will be logged into Zoom with your camera on. So I will see you on Thursday for the quiz.